a Sterling Power Products Pro Power Q 600 watt Quasi Sine Wave Inverter. And a faulty one at that. That was a bit of a mouthful. So I purchased it off eBay for spares or repair. I'll just bring the listing up so you can have a look. And I paid £3.65 for it and £2.87 postage, so a total of about £6.50. Right, let's get it out of the box. So the seller described it as pretty much dead, not doing as intended. So it came with the manual there. I'll just get that out of the way. And this is the unit here. So I think I'll quickly hook it up to the bench power supply and we'll see what it does, if anything. Right, so I'll just go and sort that out. Right, I've got the bench power supply hooked up to it, and I've just got it set to 13.8 volts at 2 amps, just in case it decides to catch on fire or short out or whatever. So that's the power supply on. Now we're just in volts DC. I'll just turn that up a fraction. That'll do. Right, let's switch this on and see if anything happens. And it's not drawn any current. And we've got no lights on it. And it is switched on. Right, I think we're going to take it apart then. I'll just switch this power supply off for the noise for now. Right, so how do you come apart? Well, so we've got 4 screws at that end. And 4 screws at that end. Let's try this end first. Right, well, it doesn't appear that that end wants to come off. I'll try the other end then. Right, there we go. Does this plate slide off? Yes. Right. Right, let's zoom down a bit and we'll have a look. Well, the first thing I've noticed is we don't have any fuses in it. Looks like we've got 3 fuse holders there, but no fuses. Now surely they just haven't taken the fuses out. I suspect there'll be more than that. Looks like we've got a load of MOSFETs along here. And another 4 down here. But I can't see any exploded components or anything, so that looks a good sign. And I guess this back panel wouldn't come any further because it's held in place by the 2 wires. Right, we'll just see if we can get these wires out of the way and try and get this back panel off or something, I think.
A few moments later.
Right, got the 2 plastic clips off at last. Right, so I need to undo this earth wire. Just put that to one side. So I don't know whether to take this whole board out and have a look at the underneath of it as well. I know a common fault on these is usually MOSFETs go. That's what I was expecting with the other one that I looked at. We might just be to get the meter in and check some of these. Let's zoom down a bit more. Right, I'll just find something to point with. Right, so we've got gate, drain and source on these MOSFETs here. And over here we've got gate, drain and source as well. So I think I'll just start by trying to check some of these MOSFETs if I can with the meter. Might have to put something underneath this board just to get it up at a bit of an angle there. And I'll zoom out a bit to try and get the meter in shot. I'm just going diode check. Right. Right, so the gate's at the left hand side. I'm just double checking there. Well, so far those ones look okay. We don't have any shorts. It's usually when MOSFETs fail, you usually get a dead short. That's just me touching the meter probes together. Right, well, we don't appear to have any shorts on that side. Let's flip this round. And we'll just try the same on these ones. Right, so there we go. Right, so on this one, the gate is at the left hand side. And then we've got the drain and then the source. So it looks like we've got a short between the gate and the drain there. Now these are probably wired in, or two of them at least will be wired in parallel. So I'll probably get the same reading on the next one along as well. Let's try the next one along. Right, well, we're not getting any short on that one. Let's just try this one. Right, so that one seems okay. So we've at least got one, possibly two shorted MOSFETs. Now the problem is when these blow, they sometimes send power back through down the gate pin to whatever controls the gate pin. I mean, there's some opto-isolators here, so they may be opto-isolated, which would be good because there'll be less damage if that's the case. So I think the next thing is to take all of these heatsink bracket things off, and we'll have to do them on both sides and then see if we can slide this board out and we'll get a look at these MOSFETs. Right, so let's start with this side, I think. Right, so let's let them four off. Let's just flip it around and we'll start taking these ones off. So perhaps we should talk about how these work. So we've got the 12 volt comes in here. It'll most likely be switched by these MOSFETs here because there's more of them on this side, because there'll be more current on this side than what there is on the output, so we'll need more MOSFETs. They're probably wired in a half bridge configuration because there's two. It's pretty much two inverters in this to double the power, I think. So they'll be wired in probably half bridge configuration, so it'll switch one side then the other on each of these transformers. The power then will go through these diodes here, be rectified to DC to these capacitors. So we'll probably have, you know, maybe 400 or whatever volts DC on these. And then these MOSFETs here are what switches this DC voltage back into AC, which then feeds the output socket. And it's probably controlled by that chip there. I can't see what the number is on that. Let's just have a quick zoom down, see if we can see what number's on it. Let's flip that round, make it easier to read. So that looks like an EM7 8P458. Now, I've not heard of one of those before. Well, I'll see if I can pull a data sheet up for those playing along at home. Right, let's see if we can get this board out. Actually, I wonder if that's a microcontroller or something, just with it having the crystal there. Right, let's see if this board will slide out now. I might have to release these MOSFETs from their insulation strip here. I'll try a bit IP, I think, on this. Right, there we go. Oh, we've got another earth strap there. Missed that one. Let's have a look at the bottom of the board then. Right, we'll zoom down a fraction. It actually looks in fairly good shape, this. I can't see any dry joints or anything, or any blown tracks. So it could well just be these MOSFETs here. Let's see if we can get these little plastic cover things off insulators. Let's see what MOSFETs these are then. So it looks like IRF 840. Right, so we've got one here and one here. Right, I'm going to put some fresh solder on these first, just to help it conduct a bit more, because you can see there it's not wanting to melt. I can't see any conformal coating or anything on this board. Let's try turning my iron up. I expect to pull these straight out. Right, there's one out. Yeah, I think it has got some kind of coating on this board. Right, that's the two MOSFETs out. I'm just going to put a bit of flux on these pads here. And then I'm going to clean them off with a bit of solar wick. I'm just going to clean that up with a little bit IPA. Right. Let's get me sort out of the way. Yeah, so that one's shorted. Shorts on all three legs. Let's try this one. Yeah, so both of those definitely shorted, so those need to be replaced. Let's see what else we can see then. Let's try those ones again. Yeah, I think it does have some kind of conformal coating on this board. Right, let's see if we can trace what's next in the circuit. I've got a diode there, let's see if that's blown. No, that seems okay. That one seems okay. I've got another diode here, let's try that one. That one seems alright. I've got a transistor here and a transistor there, let's try those. Let's go diode check. Right, so that one seems okay. Let's try this one. That one seems okay. Let's just try this diode. Yeah, that seems fine. I'll try that one. Yeah. Right, so most of that area seems okay. Yeah, and it is opto isolated from here. So I guess those opto isolators will be what's triggering these MOSFETs to generate the power or switch the power. Yeah, so the output just comes straight from here, so yeah. So I think it's just those two MOSFETs. I think if we replace those, replace the fuses, it more than likely will work. I mean, there's a couple of capacitors here. It might be worth just checking those. But I might just check those in circuit with the meter just to get a rough idea. I mean, it'll not be 100% accurate, but it'll give her a rough indication. So if I can see any values on these. Well, I think that's it, 22 microfarad. Anyway, it might be easier to zoom down because my eyes aren't very good looking at this. So we've got a 47 microfarad and a 22. And a 22 and what's that one? Must be behind that brown wire. 22. Or 2.2 is that? Yeah, 2.2. Actually, yeah, they're both 2.2. So we've got a 2.2 there and a 2.2 there, right. Right, so we're going to capacitance mode on the meter. 2.1. It's not far away from 2.2. 2.17. Right, where was the other one? It was about here. 2.12. Right, I'll see if I've got any of these MOSFETs and then we'll change them. Right, I've got a little box of MOSFETs here. And this was an IRF 840, wasn't it? Yes, IRF 840. Let's have a look then. IRF 840. And IRF 840, right. So we'll just trim these so they're the same length as the originals. I know the other two aren't gone, they're both okay, but I might just change them just in case. Now the reason is, if those ones have blown and then these ones have trying to switch on, it may have well weakened these ones. So the point that they're still working, but they may, you know, maybe slightly damaged. So I think I'll change them ones as well. I might as well put the 4 in. Right, I'll pull the other two out as well. I guess that they'll be the same, but we'll best double check. There's that one out. And there's the other one out. And again, we'll just use a bit of solder wick just to clean up the excess. I'm just going to give that a bit of a clean up again. Right, let's check what these ones are then, if they're the same. Let's just zoom down a bit. Yeah, and they're IRF 840s as well. Right. Right, so we'll change all 4. Right, that's one in. Right, 2. Just give my solder 9 tip a quick clean. Right, that's 3. Right, and number 4. So I don't know why the previous owner removed the fuses, unless they had all gone. Right, let's see. Looks like those ones might have been getting slightly warm. Might just be the colour of the. Yeah, I think it's just the colour of the tab, and just looked a bit discoloured. I mean, it could be that they have been getting warm. Right, so I don't know whether just to try it, just like the way it is there, then I think it's probably going to be easier than trying putting it all back together at the moment. I will not put any load on it. I'll just find a couple of fuses and then we'll connect it with the bench power supply again. Right, back with some fuses. So I think this should have 3 25 amp fuses, giving a total of 75 amps. Right, I need to spin this round and tell you what, I'm just going to use my little Milwaukee Hoover here just to clean this bench up. Fixed this one ages ago and it's still working. Right, let's get the bench power supply and that hooked up. So we'll not be to do a load test with the bench power supply, but at least we'll be to see if it works, and then I'll see if I can sort out something so we can try it properly. Right, we need to plug the fan and that back in and the on-off switch. Right, something like that. Switch the power supply on. Right, I was getting a little click there. Oh, I've got a green light on. So that looks a good sign. Right, I'm just going to get the meter a sec. And we'll go on to volts AC. I'll just switch this back on. And yeah, there we go, 238 volts. So I guess it was just those two MOSFETs there. Right, we'll switch this back off for now. I'll let this discharge a bit. We'll put it all back together in the case, and then I think we'll just give it a load test. I'll see if I can find a small 12 volt lead acid battery that we can hook up to it, and then we'll try putting something properly on the output. Right, so that's been off quite a while now. Let's see if we can get this back in its case. Right, I'll turn it round and we'll do the other side. Need to put these insulators back on. Right, I think just the bottom to go back on now. Just check that wire. Not sure which way that was supposed to go. Right, I think before I put those two clips on, we'll test it. Right, so what I've done, I've brought my big jump starter here, which I've connected up to the inverter, and I've plugged a 4-way extension into it, and the reason for that is I thought we'd scope the output. So I've got my scope probe just poked into this figure of 8 lead here. So I'm going to start recording the scope screen so we can see the output waveform as well, with this being a quasi sine wave inverter. So we'll see what the output looks like. And for load testing, I've got this little cupcake baker type thing here, which is 520 watts. Just here. So I thought, well, that would be quite a good test just for some kind of load on it. So let's plug this in. and I'll get the thermal camera out as well, so we can see that it's actually heating up. Right, so let's open that up a sec. Trying to balance everything. Right. So I'll get the thermal camera out. And I'll just start recording that as well. Right, so if I switch this inverter on now. And the battery bank. Right, well the fans came on, oh, there we go. And we can see the waveform on the scope as well. You can see the temperature increasing there, 37, 39, 40. And that's the battery going flat on the on here on the road starter. It's actually just complaining that it's on. But at least the inverter's working, so that's all good. Right, nice. Right, well, I really enjoyed this repair. I think it was a really nice one to do, and yeah, I'm really happy with that. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.